In this video, I would like to show you how we can create complex gameplay sequences in Unreal Engine with a plugin I developed called Actor.io. It is an open source level scripting tool built on the C++ reflection system of Unreal Engine, and it allows you to connect actor logic together directly in the level through a custom action editor. Take a look at this example. There is a cube here at the end of this hallway that you can imagine this being a monster, for example. Now, I want to make it so that when the player approaches this cube, it disappears. First, I'm going to place a trigger box in the level and scale it up a bit so that it covers the entire width of the hallway. Next, I'm going to open the I/O editor by going to Window and selecting Actor.io. This is the main editing environment of the plugin, where you can connect actions to certain events happening in the game. I'm going to select the trigger box again and add a new action to it by pressing the New Action button. So in this case, the event will be onTriggerEnter. The target is going to be the cube, and you can see that as soon as I select the target, the connection gets visualized immediately in the editor. Now I just need to select the action to call, which in this case will be destroy. Since the destroy function doesn't require any parameters, we can leave it empty. If I start the game now, you can see that the cube gets destroyed as soon as I enter the trigger. Let's make this a little bit more interesting by also playing an effect when the cube is destroyed. From the engine folder, I'm going to add a simple radial burst effect to the level, and I'm going to disable the auto activate option because I want to manually activate it from the trigger itself. So now I can add a new action to the trigger, select onTriggerEnter again, and this time I'm going to pick the radial burst as the target and simply tell it to activate. You can see that the activate function requires a parameter. If I click in the parameters field, the plugin will display the list of parameters automatically that are required by this function. In this case, there is a bool parameter called reset, which sets whether we want to fully reset the effect before activating it. And if we start the game now, you can see that the cube gets destroyed and the effect is activated immediately. This approach to level scripting is similar to the Source engine that Valve used to develop games such as Half-Life and Left 4 Dead. The same goes for the Doom series developed by id Software or Alien Isolation developed by Creative Assembly. These are huge AAA titles that all handle level logic in this way. Of course, simply connecting actors together in and of itself is not enough. The true potential lies in the ability of creating small script-like objects that handle a specific task. For example, adding an item to the player's inventory, updating the current objective, spawning enemies, starting a dialogue with an NPC, or triggering level-wide events. In Actor.io, these scriptable objects are called logic actors. To help with more complex level logic, the plugin comes with a collection of logic actors such as branches, counters, and timers. Custom logic actors can also be created by subclassing the logic actor base class. Here, for example, I'm going to toggle the value of a branch when I interact with the switch on the wall. Then, from the branch itself, I can use the onTrue and onFalse events to open or close the door. And if you want to get a better understanding of how a level is structured, you can switch over to the Inputs tab, where you will be able to see all actions that are targeting this actor. Using the Find button at the end of each action, you can jump to the calling actor, where you will be able to see and edit the action itself. The great thing about this system is that it is very flexible and designer-friendly. You can easily expose new events and functions to the I/O system simply by adding the I/O interface to your actor and overriding the register I/O events and functions respectively. Here, for example, I'm going to register the onHit event of this target dummy. Back in the editor, the registered I/O events and functions show up immediately. No editor restart is required. For example, I can now use this onHit event to increment the value of a counter. Since the plugin supports dynamic parameters, I can update the 3D text below the actor to whatever value the counter currently has. Now, it is important to note that the I/O system is not a replacement for blueprints. What the I/O system solves is simply the communication between different actors in the level that are otherwise unrelated. It also creates a clear separation between events and functions, avoiding a lot of duplicate classes and promoting a more modular design. Keep in mind that you do not have to choose between the I/O system or the level blueprint, for example. You can selectively use each where it makes sense for the game. The I/O system is just another tool in your toolbox. As I mentioned before, the plugin is free and open source, with an optional paid donation edition on the FOB marketplace. This paid edition only contains small convenience features, such as having the plugin pre-compiled for the user. For the sake of brevity, here is a quick summary of additional features that are not showcased in this video. Thank you for listening, and have a great day.